students, in this video we are going to find out even and odd parts of a given signal x of t. So signal is like this. So this is a signal given x of t. We need to find out its even and odd part. The procedure is very simple. Step number 1 is to get time reverse version of this signal, which is x of minus t. So we will get a time reverse signal like this. So x of minus t is like this. Even part we know is given by half x of t plus x of minus t. So x of t was given and x of minus t we obtained by doing time reversal of x of t. Now we need to add these two signals. So addition of x of t and x of minus t will give you new signal x of t plus x of minus t. Let's add the signals now. Let's start with the 0 instant. So I can see over here for both the signals, for t equal to 0, values are 1 and 1. So I can add this to give you 2. So I can say somewhere here is say 1 and over here it's 2. So for t equal to 0, I will get the value equal to 2. 0 to 1 is a straight line which is parallel to t-axis, meaning slope is 0. 0 to 1 for x of minus t, it's a ramp but having the slope minus 1. So two slopes will get added. In the end, I will get slope as minus 1. Now we need to find out what should be the value at t equal to 1 in both the cases. Here it is 1, here it is 0. So if I add, I will get value equal to 1. Meaning I should get a straight line with the slope as minus 1, but at t equal to 1 it should reach a value equal to 1 and then immediately it should go to value equal to 2. So see how I am going to draw this. So from here there should be a slope of -1, and we should get a value equal to 1, and immediately it should go to value equal to 2. So we will get a characteristic like this. Now let's find out what will happen from 1 to 2. From 1 to 2, here a slope is 0, here also slope is 0. So in the end, 0 slope, but it's a constant value of 2. Here it's a 0, addition will become 2, and at t equal to 2, both is reaching to 0, meaning resultant should be like this. Now same thing we can apply for negative axis. From 0 to -1, here slope is -1, slope is 0, resultant slope is -1, and at t equal to -1, it's having a value 0 and it's having a value 1, which is changing to 2 immediately. So the transition should be like this. There should be a straight line of -1 slope, and it should reach equal to 1 as the value, and immediately it should go and we should have the value equal to 2. And from -1 to -2, this value is 0, this value is 2, 2 value will be continued, and in the end here nothing is present, means 0 value, this value is becoming 0. So at t equal to -2, the signal should drop down from 2 to 0 like this. So I will get this signal, but this is not an even signal because we need to divide whole by 2. So in the end we will do amplitude scaling without any change in the t-axis. And the values we will get will be like this. Here you will have 1 and here we will have 0.5. This is 1 by 2 bracket x of t plus x of minus t, and the signal we obtain will be like this. We can see the signal is symmetric about y-axis, hence we can very well say this is even part of x of t. Similarly, we can find out odd part, but for that we need to write an equation. So odd part of any signal will be given as half bracket x of t minus x of minus t. So now we need to do this calculation, x of t minus x of minus t. So this is the original signal x of t, time reverse x of minus t. So span of the signal will be from -2 to 2. So see how we are going to calculate x of t minus x of minus t. Let's start with a 0. So for x of t equal to 0, we will get a value 1. For x of minus t is also value 1. So 1 minus 1 is 0. Then 0 to 1, slope is 0. Now let's subtract x of t and x of minus t. So we have x of t and x of minus t. Now let's start with a 0. So 1 and 1 get cancelled, and in the end I'll get 0 for t equal to 0. 0 to 1 for x of t, it is having a slope 0 and value equal to 1. Whereas for x of minus t, slope is minus 1, and for t equal to 1 it is reaching the value 0. So if I combine these two, I will get resultant slope as minus 1, and that minus 1 slope for t equal to 1, we should get the value equal to 1 minus 0, which is 1, and that should be shooted up to the value equal to 2 because of this nature. So overall we will get structure like this. Slope is 0, here slope is minus 1. Subtraction of these two slopes will give you a resultant slope as 1. So we will get slope equal to 1. And as I said earlier, immediately that should be shooted up to the value equal to 2. And after this 2 value will remain. Thereafter here it is 0, so subtraction is 2 only. So I will get signal like this. Let's find out the signal in negative t-axis. Once again, from 0 to minus 1, slope is minus 1, slope is 0. Subtraction of these two slopes will give you a resultant of slope minus 1. Values over here is 1, here is 0. So 0 minus 1. So I should get a signal with slope minus 1 and value equal to minus 1 only. And then here the value is shooting from 1 to 2, but this is 0 only. So 0 minus 2 will be the minus 2. And we'll get minus 2 thereafter because of here it is 0, here it is 2. So in the end we will get a signal like this. So this is x of t minus x of minus t. Which need to be divided by 2 in order to get the odd part. So we do a amplitude scaling like this. Instead of 1, we will have 0.5, and instead of 2, we will have 1, because we are dividing by 2. Same thing will happen for the negative axis as well. Minus 0.5 and minus 1. So if we draw, we will get a signal like this. Which we can say 1 by 2 x of t minus x of minus t. So if we see properly, it is passing through origin. At the same time, a reflection version or a time reverse version is negative that of the original version. So I can see this signal is a odd part of x of t.